Hey guys! Today we're going to get into the fun stuff. Now we're going to be introducing the symbols that we will be using to draw circuits for the rest of this unit. Okay, so the first thing we have to do is talk about the types of circuits that we're going to be looking at. And we are going to learn these in order of this slide. So the first thing you're going to learn after this set of notes is series circuits, how to calculate and combine series circuits. Then you're going to learn parallel, then you're going to learn combination, etc., etc. So the first thing you need to know that a series circuit is a circuit where there is a single path of travel for all electrons. So if I make a battery and add my wire, there is one path. There is only one line connecting one side of the battery to the other. So series circuits are a single path of travel for the electron. Parallel circuits, here's my battery again, you have multiple paths you can travel. So you can go through that rung of the ladder, or this rung of the ladder, or this rung of the ladder. The important thing is that there is a location where you can fork off into one of two directions, then you come back together, and then you come back together with the rest of the electrons. So notice, one path only. This has multiple options of paths that the electrons can travel. Okay, the last thing is a combination circuit. A combination circuit has some stuff in series and some stuff in parallel. So there might be a light bulb here and then a light bulb here and here. So the electrons have to go through this first light bulb. Then they can choose if they want to go to the left light bulb or the right light bulb. So series have one path only. Parallel has multiple paths of travel, and I like to call them rungs of a ladder because it kind of looks like a ladder. And combination circuits have a little bit of both. Okay, so those are the three types of circuits. Now we're going to get into the stuff that we put onto circuits. The first thing that you need to know is batteries. A single battery is shown with a tall line and a short line. And then we have the wire connecting it to the left and to the right. Okay, so I had that on the last slide, so that shouldn't be too much of a stretch. Multiple batteries are shown similarly with tall lines and short lines, but you can pair them up into as many as you need for a circuit. So this is 3 batteries because it's 3 sets of tall, short, tall, short, tall, short. Next is a wire, and that's simply being shown by a straight line. Now I like to create my wires in squares because it's a little bit neater than if I were to do a circle for a circuit. So in class, I'm going to draw them squared off just because it's slightly more organized. Now, in order to turn a circuit on and off, you need to have switches. So an open switch, we would have our wire coming in and a dot at the end, a second dot a little bit away, and a wire going out. And it looks like having an open door from above. So this is another section of wire, it just isn't touching the other dot. This is an open switch, and when this is open, this means that the circuit is off. Because right now, the electricity cannot travel through this wire since it is not being connected to the other side. Now a closed switch is the same drawing, but with the wire closed like a closed door from above. And if this is happening, our circuit is on. Now these two things, an ammeter and a voltmeter. An ammeter tells us how much current is traveling through the circuit. Our ammeter is shown as a capital A with a circle around it. But our ammeter must be added in series to the rest of the circuit. So if we have a battery and we add our ammeter here, then we have a light bulb and our battery. If we have a parallel circuit and we were to place the ammeter on this line, it will only tell you the amount of current traveling through this light bulb. If there's a second rung of the ladder, you would have to put it on that second rung to determine how much is traveling through that second item. Now a voltmeter tells you how much energy is lost at a resistor. And a voltmeter is a capital V with a circle around it. This has to be added in parallel to whatever that item is, and I will draw a picture of that down here. So if we have that same light bulb drawn in series as that first drawing up here, our voltmeter has to be attached in parallel, one clip has to be before the light bulb, and one clip has to be after the light bulb, and it will tell you that from this point to this point, we lost 3 volts of energy, or 9 volts of energy. So an ammeter must be added in series, and a voltmeter must be added in parallel. Ammeter tells you the current traveling through that section of the wire. Voltmeter tells you how much energy is lost at that resistor. Okay? Last 3 things. A light bulb. A light bulb looks like this, like Charlie Brown hair, or a squiggly line with a circle around it. Okay? Now, when I draw in class, I tend to draw quickly, so I'm going to do this for my light bulb. They mean the same thing, it's just a faster way to draw it. A regular resistor, that's like a hair dryer or a radio or an oven. That is shown using a squiggly line. Okay? That's just anything that can be plugged into an outlet. Light bulb is a specific something, but any other resistor is just a squiggly line. And then the last thing is a motor. A motor is drawn by adding 2 open switches, so open switch, and then coming in from the other direction and going downwards is an open switch, and then a circle in the middle. Okay, so that's our motor. So these 3 things can be added to our circuits also. So now we're going to put this all together. We're going to draw a series circuit with 2 light bulbs and 1 battery. So there's my battery. There's a light bulb and a light bulb. Okay, now you could have drawn battery, light bulb, battery, or you could have drawn as long as there's only one path of travel, any of these are considered correct. So a series circuit with 2 light bulbs and 1 battery, these 3 options could all be considered correct. Now we're going to draw a little bit more advanced of a circuit. Draw a circuit with a bulb and a motor in parallel with each other, a switch and 2 batteries in series. So I'm going to draw the switch and the battery first. So it didn't say open or close, so I'm just going to make it open so we can see it. Tall, short, those are my 2 batteries. Now I have to add a circuit with a bulb and a motor in parallel. That means there has to be a fork in the road. So I'm going to go this way, and I'm going to add my light bulb first. That's my first path of travel. And I'm going to build up from that to draw my motor. Okay? So here, these 3 items are in series because there's only 1 line connecting them, but the light bulb and the motor are in parallel because they are on different rungs of a ladder. Okay? So the first thing we're going to do is practice drawing some examples of circuits before we get into how to calculate things. I want you just to be able to draw them before we can go any further. So I'll see you in class so we can draw some circuits together.